Welcome to 1.3 Algebraic Expressions. What is an algebraic expression? Well, let's give an example. 4n plus 3. Hey, that's an algebraic expression. What is this n thing, though? Well, that n is a variable. And you need to know that because it can be any number. You can also use any letter to represent it. You don't just have to use an N, which I used, so can be any letter. Whatever one you want to choose. I choose N because N stands for number in my mind, so I like using N. Alright, let's move forward. What do you notice here? You see the 4 and the N right beside each other. Well, what is that? What does that mean? What's going on here? Well, that's the same thing as saying 4 times n. We don't have to, in algebra, we don't have to write 4 times n. It's just some crazy rule that these old fogies from a long time ago started, and it's just become popular. Kind of like your LOLs and BRB when you're texting. Well, that's what they did here. It's kind of similar to that. So we just do it, but they only do it for multiplication, so too bad. So the next thing is, we need to, now that we know what an algebraic expression is, we know what a variable is, we need to move forward and find out from reading how we can figure out what our expression is. Now, there's a few buzzwords that we have to remember. So if we're looking at adding, okay, sometimes in a sentence they'll tell us to, adding is more, increased by stuff like that. That gives us an indication that we need to add. Now subtraction, same thing. You can say minus, less than, stuff like that. Multiplying has their own words too. You get the product. Okay. They could say times. Okay. And division has similar ones as well. They could say quotient and divided, okay, stuff like that. So as we move forward, you're going to understand what I'm talking about here in a second, because I'm going to write an example for you. So let's take a look. 3 more than a number. So we have a sentence here, a fragment sentence, whatever you want to say, and it's telling us to do something. We have to make an algebraic expression from this. So how do we do this? 3 more than a number. Well, 3 more than a number. There we go. 3 plus n. It can also go n plus 3 because adding is commutative, so it can go either way. It doesn't matter. What about another one? Let's take a look. 7 times a number. 7 times a number. Oh, 7 times a number. Remember, we can write it that way, but we can also write it this way too, 7n. Okay? We're getting the hang of this? Let's try another one. 8 less than a number. Well, it's 8 less than a number. Some of you probably are thinking 8 less than a number. Very tricky. You got to pay attention. You can't actually write it that way because it's 8 less than a number. This is wrong. It should be n minus 8. Okay? So it's 8 less than a number. So the number, and there's 8 less. You have to be very careful when it comes to subtraction because remember, it's not commutative. If you do it the wrong way, you're not going to get the right answer. You're going to get an integer, which we do not want right now. Okay, let's see. Here's another example. A number divided by 20. Hey, all right. So a number divided by 20. Well, a number divided by 20. N divide by 20. You can write it that way. You could do it this way. All right. All right, let's move forward. When we want to evaluate an expression, we will then replace the variable with the number in an algebraic expression, and then we can solve it. But until then, it's just an algebraic expression, we can't move forward. So for instance, the 4n plus 3, until we actually get what this is, we cannot solve it. Okay, so let's say it was 2 plus 3. So now it's 4 times 2, which is 8 plus 3 is 11. See how we can solve it now that we know what this is? So we can't solve it until we know what this is. Okay, let's take a look at some other examples of how to evaluate. Let's say we have 5k plus 2. And they're going to tell us that k equals 3. So let's put it in. 5, and I'm going to write this way, times 3 plus 2 equals. Now we know that according to order of operations, the multiplication has to come before the adding. So what's 5 times 3? It's 15 plus 2. So that's 15 plus 2 equals 17. You notice how I'm writing down all my steps here? You better do this. If you do not write down your steps, you are going to get in trouble, because all teachers want to see your work. If you're not showing your work, you're going to lose marks. Don't make me repeat this again. All right, let's take a look at another example. How about we do 32 minus x over 4. And we're going to make x equal to 20. Excellent. So let's take a look at this. Well, we do 32 minus 20 over 4. So I rewrite my equation. Look at this. It's all coming nice and neatly straight down. So the next thing I can do, well, 32, following order of operations, I have to do my division first. Minus, so it's 20 divided by 4 is 5. And 32 minus 5 equals 27. Excellent. So now that you have seen a couple examples, I'm going to mention one more thing, and that's it. And then you guys are going to go on your merry way and do your own work. Let's take this one again, 4n plus 3. There's some things that you need to know exactly what they are. They have names for them. We already talked about this being the variable. You also need to know what this is, and this is called a constant term. Constant term. Now, the other thing you need to know is, what is this 4 right here? Well, that 4 is called a numerical coefficient. Okay? I think that's about it, folks. I think you can now go ahead and do some exercises on your own.